Excellent. Recording has started and I don't know why it's doing that.
I'm hoping my screen's not gonna spaz out again.
I'm thinking that our Promethean board is spazzing out because the weird way that this cord is bent. So if I go like this, then it will not. All right. Hopefully that will fix. Well, we are in Precalculus. We are on the day before Pi Day, the 13th of March, 2023. But if we write it in the European style, then it doesn't make sense that Pi Day is the 14th of March, because now it's backwards. We would have to write it the American way, 3/14, right? But whatever. Pi Day is tomorrow. It's the day that we celebrate. I'm not going to change it. We don't have the 14th month, so we can't write Pi Day in that other way. Yeah, today we're solving logarithmic equations, and then we're going to do harder logarithmic equations later in 3-11. Let's go ahead and take a peek. Yeah, 3-11 is a slightly harder version. So today is the basic version, and then 3-11 will be the advanced logarithmic equations. Tomorrow will be 3-11, I think. Yeah. All right. So I'm just going to jump straight in with an example. Example number 1. What if I give you an equation that looks like this? Log base, I don't know, shout out number 5. Log base, are you looking at number 1? Log base 5 of, I'll make our variable x is equal to, shout out another random number, not -2. 7. There it is. How do we solve for x? Diego knows.
You log both sides.
If we log a log, we have a double.
Oh, no. You have to get x by itself, don't you? So you would log, you put log of 5.
We'll be back to however many weeks ago, like 3 weeks ago, when we were practicing going backwards and forwards, how we take the inverse of a logarithm. Well, I can tell you this, off to the side, you might remember that if I have 5 to the power of x is equal to 7. What I could do is I could take the log of both sides, and I could do log base 5 of that thing is equal to log base 5 of this thing. You could fill in what was originally there, 7 and 5 to the power of x. So exponents, the opposite of exponents were logarithms. So what I'm doing now is I'm doing that backwards. How do I do the opposite of a logarithm?
Natural log.
Anyone on Zoom know?
Isn't that the exponentiation?
Exponentiation, exactly. So what I'm going to do is I'm going to rewrite this in a second, but I need to choose the base. What base should we choose? 5, because this is the base 5 logarithm. So I'm going to say 5 to the power of log base 5 of x. And that's going to be equal to 5 to the power of 7. That is, again, if you don't know this word, I'll write it down. From here to here, it's called exponentiation, aka putting it to the power of an exponent. You get to choose whatever base you want. You always get to choose the base. If we had a logo for Precalculus, maybe there would be that for next year. This year's logo is everything is complex. Maybe next year's is you get to choose the base. It doesn't have a nice ring to the logo. All right, and now it's a little bit hard to explain, but these do all cancel out. 5 log and base 5 all do cancel out, and that is an x, and we have a 5 to the power of 7, and the other box. 3 weeks ago? It is 3 weeks ago, yeah.
Because we're trying to come back to school and we ended up.
Yep.
You almost had a full suit.
I know.
Yeah.
All right. Let's do a hard written test. All right, you guys get to choose how quickly we advance. Do you want an intermediate and then an advance, or just jump straight to an advance?
Intermediate.
There are 2 intermediates. That probably will outweigh anyone on Zoom anyway. Let's do an intermediate. Let's go ahead. Shout out a number. 6. We'll say plus, and then give me another number.
7.
Oh, 7.
Log base 7 of, I don't know, shout out another number. 10. All right, we'll say, it might be, right, we'll say X and 10, sure, like that. Oh, this one doesn't work. Will I give you any that don't work? Let me check that. No, I always make them work. We'll have to modify this problem, so you'll have to erase, but can I really quickly explain? Oh, this one will work. The one thing that you have to be careful of when you make your own problems is if you have something isolated where here's something bad I can have. All right, this is bad off to the side. If you have something like log base, I don't care, 2 of x is equal to negative something like -8. That's a problem because logarithms are never, oh, the logarithms can be negative. Exponents can't be negative, but logarithms can be negative.
Wait, exponents can't.
So this is actually, I'm wrong. I thought I was thinking ahead, but I was really thinking of this. Like 2 to the power of x is equal to -8. That can never happen. That is indeed bad. This one's okay. You are allowed to have negatives with logarithms. You can't have negatives with exponents because it doesn't matter what you put up here. If the base is positive, a positive times a positive times a positive, however many times you want, it's never going to be negative. Yeah. All right, so that's a long-winded way of saying it doesn't matter what we choose. Negatives and positives are all fine for these examples. All right, so we need to isolate the logarithm. If I just have this logarithm isolated, then I'm ready to go. So I need to get rid of the 4, I need to get rid of 6, and then for Gucci. We're going to get rid of first, before 6. I don't know. Maybe that's your one. The Zoom kid can't see. That could have been Diego.
So we're gonna subtract 6 from both sides.
We do need to subtract 6 on both sides, so I now have 4 log base 7 of x. Why do I need parentheses? I don't know. I'm being pedantic. All right, is equal to, okay, subtract 6 on both sides, so it's now. Responded as a 4.
I never expected you to say.
Oh, shoot, we made this problem too easy. You can actually solve this without exponential. Okay, it's okay that we made it too easy. It's okay. It's an intermediate question. Okay, from here, let's give it to a Zoom kid, either Alden or Chloe Zoom kid. What do we do now?
Divide by 4.
By 4, and you get now what, Alden?
1. Well, log base 7x, and then on the other side 1.
And the weird thing about this is this does not require exponentiation because we made it such an easy problem.
But say we did, wait,
But let's go ahead and say, I didn't know how to use properties of logarithms. Let's say I'm just gonna go brute force and do that procedure no matter what. Is an okay strategy. That means that I'm going to do exponentiation and choosing a base of what, Chloe?
7.
7. So we're gonna go ahead and say now this is gonna be 7 to the power of log base 7 of x is equal to 7 to the power of 1. Ah, good. So someone else answer Emma's question. Emma said, hey, when we got from here to here, when we subtracted 4 on both sides, 4 minus 4 should have been a 0. How do we get this 1?
future error.
Divide.
Yeah, we did minus 4 weeks. Divide by 4.
Yeah, that makes sense.
Divide by 4, subtract 6 here. Now I'm trying to work, right? And if I'm really doing that same thing, I would say exponentiation.
So if we didn't do it on this one, since it doesn't require it, we just stop at log 7 x equals 1.
No, it's 7.
Wait, doesn't the 7 cross out with the log base 7? So then it's just x equals 7?
Or 1, right?
Yeah, 7 to the power of 1 is just 7. Yeah, and you guys can probably see if we back all the way up to right here. 7 to what power gives you? No, that's not right. 7 to the x power gives you 7 to the power of 1 is what? I guess is the question. 7 to what power? And what power has been answered for us? 7 to the first power is what? 7. So you didn't really need to actually do exponentiation.
We just had to use our brains right there and say,
If you use the what power function, to just use our brains, yeah. 7 to what power? 7 to the 1 power is what? 7 to the 1 power is 7. All right. finally, a hard example. Let's make this one truly disgusting. Here we go. Example, I'm gonna need a lot of numbers. Get ready to shout them out. Example 3. All right, shout them out. Let's make it a -4. A -4. Let's make another negative. Shout out a number. -9. We'll make a log base.
Let's see, how about we go with lucky number 3?
Log base 3. Give me 2 more numbers for the inside. Mono city kids, or well, I guess
7 and 8.
7x minus 8 is equal to, we'll get played the last one.
9.
9. And we don't have to worry about negatives. This one will work. This might be disgusting, and it will be disgusting. Number 9 and 10 on the classwork and the homework are going to be disgusting. So again, what we're trying to do is we're trying to isolate just the logarithm, meaning we need to get rid of u, and get rid of u, and then do exponentiation and then algebra. So first step.
Add
Yeah.
4.
I didn't touch anything. That's good.
That's good.
Yeah, so to get from here to here, we're gonna add 4, and I now have. Our Promethean board is like flickering at us. It's really just unsettling.
No, something's better pop out of there. Something's better pop out of there.
Log base 3 of 7x minus 8. And if we add 4 to this, 4 plus 9,
Oh, it's
13. Good. Next step.
Is that divide or add?
Ooh, that's a good question. Is it add 9 or divide by -9?
Shouldn't you divide?
Why?
Because it's -9. So -9 is being multiplied by that log, not being added or subtracted.
Always do the operation that's happening in between. In between right here, there's nothing which you assume is multiplication. You don't just look at that -9. What happened in between? Well, yes. The in between, this -4 should have been like over here. It should have been -4. The minus sign was in between in air quotes. And then the opposite of that minus sign would have been a plus sign. So excellent. We'll divide both sides by -9, meaning we get just the log base 3 on its own with a 7x minus 8 as the argument. And over here, it's this disgusting 13 over -9. It's gross, but it happens. What I'm trying to do on the classwork and the homework, we'll see if I actually did a good job. I make the fractions come out really nice. Even in the discussing problems, the answer will be like 1/4. And this one is gonna be gross. All right. Example number 3. I will never make a discussing problem like this on a quiz or a test or a homework check. All of your assessments will be nice. Now what do we do?
It could be 3 to the power of log and all that.
Yeah, so 3 to the power of log all that. There's 8 equal to 3 to the power of 13 over -9. What is that point? What is that process called? Someone aside from coding, she have
Exponentiation.
I realize I'm going fast though, because Diego is writing stuff down, Chloe and Alden should be writing things down, since I can't really print them out and copy the notes unless they're here. I mean, if you really want to wait for all the notes, you can, I guess.
I mean, you can also like access them on.
I'm writing my notes.
Good job, Chloe. Yes, you could access them all.
Yeah.
See,
Thank
we're
you,
all
Alden.
doing such a good job. I assume we all deserve like sneakers again.
Or candy.
Yeah, I get it.
All right, cross, leave this with just 7x minus 8
Like the same.
is equal to that disgusting 3. I want to pull a negative out from -13. Make sure that when you're writing your notes, your power is small into the top right, so you know that it's a power. Too many times I'm seeing kids write 3 -13 9 like, what is going on? Are you subtracting my fraction? All right, and there's 2 more steps left.
Yeah. I didn't find it.
Yeah, I don't know. I do. This was simplify. I mean, it doesn't actually matter. Both are correct. There's an easier way and there's a harder way. The easier way for next step is actually to do the thing. Plus 8. Can we add 8 and divide by 7 in the same step? Okay.
I'm just gonna do something.
So,
Do you want us to actually calculate that?
No, because in the test, the homework check, the quizzes, they will all come out to a really nice fraction. Your answer will be 2/3. You'll just leave it as a fraction. So in this case, for the notes, we'll just leave it as it's discussing whatever it is.
So the ugly thing is everything divided by 7. So I mean, I feel like those aren't that ugly. It's like I don't love it.
Can I ask a question?
Yep, and you can ask another one now too.
So when you're adding the 8 on both sides, why are you adding the 8 on the side as if the 3 to that weird fraction, like, are those not like terms?
Yeah, so order of operations states that the 3 is going to be to the power of this first. So if I were entering this into a calculator, I'd have to first do that and then add 8. So that's how I'm writing it out in terms of my orders of operations. You cannot do 8 plus 3 first. You cannot get 11 there. You have to do this after this gross power.
Okay.
Well, yeah, so you can do it term by term, say both of them are divided by 7, but what I'm going to do is just leave it as one giant fraction. I'm going to say that exact same line, 3 to the negative 13/9 plus 8, and that whole thing. So,
Wow.
I'll make the answer come out nice. Yeah, so how much time do we have? You know what,
We got a good 22 minutes.
I'm feeling the stress, and I'm sure you guys probably feel it as well. I would rather, I really like having classwork and then homework where you do homework at home. But
I mean, didn't
in a normal class, I'll do classwork and homework. Can we just jump into that homework? Because that means we'll have less homework.
Because they usually go on to the, what is it? I forget.
Oh, Sindel,
The rate for students.
Oh, what's it look?
do I have a homework check for pre-calculus to make up?
No, you sent me a picture of it. I just haven't put it in your grade book. I haven't done these guys yet either.
Okay, I just don't remember if I did that because I know I was gone for a day.
You did do it. You're pretty good.
Okay.
Also does have a 3-9 homework check. We can calculate it.
Do that today.
That is the end of the lesson, which means I should stop the recording. More and stop recording.